follow-up video to the speed of sound, velocity versus acceleration. And Deterministic One did leave a comment, so I'll deal with it. The Roberto 2 guy also left a comment confirming this, and then he took it down after I yelled at him in Tiny Chat. But I just don't think the point's being gotten, so I'll go through the point one more time and then read his comment, I suppose. But the idea is okay. The ultimate theory is you know, for whatever it's worth, is that sound is created by matter moving, an atom moving faster than the speed of sound. And the more atoms there are that are moving faster than the speed of sound, the more likely they are to create a wave in an atmosphere of material to convey the energy, the vibration that they're experiencing for whatever reason to the environment around them in some sort of manner in which it propagates in a linear manner, a non-chaotic manner. So it's more likely to traverse distance in its original condition, to retain its integrity through its transfer through the medium. And I argue that it does this through a kind of interpretation, like language interpretation, or like anything else that's altered from one form to another form, back to another form, kind of thing. And that's what's happening to the energy of the movement in the creation of sound, and that all this sound is basically sonic booms. That's basically the argument, is that all sound is created by the creation of sonic booms, by moving matter faster than the speed of sound and creating the carrier wave for sound. Yeah. Alright, and so the simplest way to visualize it is the rope, holding one end of a tight rope, and you initiate a wave in it, a lump. And you can do that, you have to do that by accelerating your hand up, stopping, and then going down. I mean, that's the general idea. As a practical fact, the medium will create the wave, in the sense that if you just did the up part at that speed, you'll create an impulse through the rope, just because of its natural tendency to get back to its original condition. It will do the downside by itself, and it can only be created. It has certain limitations of what the rope will tolerate in terms of speed. So there are speeds you could travel at that it would be difficult for the rope to transmit the impulse at that speed, because the tension, the material in the rope just won't allow it physically. But technically the idea is that you obviously would have to move your hand faster than the speed of the creation or initiation of your frequency through the rope. So whatever frequency you're creating as a wave in the rope, you would have to move your hand quicker than that frequency. And that there is a fact here in terms of when you're creating this, especially in a rope, you can visualize the fact that there is distance traveled when the rope moves this extra distance, that there is this that it's very visual. Not that sound waves are exactly the same, but it's the same in the sense that there's a tension in the molecular atmosphere that, not unlike the rope, creates dynamics that create certain tendencies. But regardless, the point I'm really getting at is that you can visualize it here in the sense that for a unit of time there will be a different distance traveled, indicating a different speed at those different moments in time. So the initiation speed would quite obviously, to create this just a basic sine wave, would obviously entail some acceleration in the first moments of the creation of the wave, and then that acceleration would decrease to zero, and there would be deceleration in the same manner. And that taking an average, like say the peak amplitude, the distance traveled would end up being an average and would not reflect this fact that there was an initial speed much higher, much greater than the final speed, and the average speed would be reflected in the frequency, but it wouldn't necessarily be found as a component unless you looked for it specifically. So, getting to Deterministic One's comment. You say there needs to be a minimum acceleration, a minimum acceleration, which is the speed of sound, but the speed of sound is a velocity, not an acceleration. Was there a point in making a distinction like that? I mean, theoretically. I mean, acceleration, let's just say, is adding to velocity, right? So that's technically what acceleration is. So acceleration is just subtracting off of a velocity what the new velocity, whatever new component you're adding to a velocity would be. But the bottom line is there are variable velocities, and that velocity is not maintained necessarily unless it's, you know, something has to, like there's all this friction that tends to take away the velocity of this waveform. That's why this waveform is created, is because of the friction being absorbed in the tension of the rope. It keeps wanting not to be accelerated, so its velocity drops as acceleration drops. So if you don't put any more energy in, it will tend to want to go back to its relaxed state. And so that sort of has to be understood, and you can sort of see that in most things that make noise there is tension in them, which sort of indicates something's going on. Anyway, as for the equation, it's just the way it is. Well, that's just a silly thing to say. My point is I'm not after an average speed. I'm after the greatest speed of what's the speed. Again, this distance is 3 times the distance traveled here. This speed is at least 3 times the speed at peak amplitude. So if you give me how far something's traveled at peak amplitude, you haven't told me how fast it might have traveled at its peak velocity. So this equation you're going to give me is not going to determine peak speed at peak velocity. It's just not. Again, and we're talking about the thing creating the sound. So again, it's like my hand moving the rope. You have to give me some explanation how your formula is going to detect how fast my hand moved at the initiation, not how fast as an average, how fast at given points in time, because at given points in time my hand will be moving faster, and quite obviously my hand stops at peak amplitude and then changes direction, and so there's a huge deceleration, so a huge detraction from velocity, a huge subtraction of velocity. So the initial velocity is the peak velocity, and it's the at peak amplitude is when there's the least velocity. There's no velocity at peak amplitude. A loudspeaker is waving back and forth at a frequency, in my example, 50 times per second. And again, that has nothing to do with the initiation speed required to create the frequency, the wave. So you're not getting to the point of creation, and your formula says nothing about time intervals, and certainly doesn't, if anything, it just gives you a average speed for the entire waveform, which has nothing again to do with the fact that there's a huge difference between the initiation speed and the peak amplitude speed of 0. Quite obviously. Alright, my example, 50 times per second, 50 square s. 2 pi times frequency is the angular frequency. Fine, but again, frequency has nothing to do with detecting peak velocity. Multiply that times how far the speaker travels in meters. Well, again, you don't know that. That's what we're trying to figure out. And you have the maximum velocity in meters per second, and the maximum velocity of a speaker at 50 hertz is much less than the speed of sound. Well, again, you're talking about the first off, you're talking about the frequency as it has been transformed by the medium, not the thing creating the frequency, the wave. And secondly, you're not describing the peak velocity of the wave as it has speed differences, as it travels more distance. It travels more distance at different periods in time. Anyhow, I think, not linear distance. Obviously, that's the whole point, right? I mean, a wave is a break from linear distance. A straight line would be a nice straight line. And a wave is a creation of distance. And the distance created is in periods of time, and there are different speeds that the wave is traveling through those periods. Okay. Anyhow, I think I must have misunderstood what you were saying before. I thought you said that the thing that is making the sound, like the loudspeaker, must be moving at or above the speed of sound in order to make a sound. Well, again, I'm going to argue the thing creating the sound, yes, must move faster than the speed of sound, and I'm claiming that the speaker is moving faster than the speed of sound at the point of initiation of a wave. Yes, a frequency. That it accelerates just like this accelerates. It has a peak acceleration and then it decelerates. So it has a peak velocity here at its origin and no velocity at its peak. So again, the speaker is going up, and it's stopping and going back down, and it has different velocities throughout that process of achieving its peak amplitude. Must be moving at or above the speed of sound. Now, I think you are saying that the thing making the sound must accelerate a medium such that the medium will reach the speed of sound. Well, the same difference. Yes, I'm saying, of course, the thing making the sound has to move faster than the speed of sound. I'm not saying the sound is moving faster than the speed of sound, because then it wouldn't be moving. But obviously elements of the wave are moving faster than the speed of sound technically, because obviously the wave is moving, the wave itself implies, like I said, if it was a rope, you could see that it must accelerate faster than it's actually moving linearly to be able to go the extra distance. So the fact that a wave moving through a rope would require it to have, it's required to have acceleration, velocity greater than its forward velocity, because it's moving more distance. The rope is physically moving more distance. Alright, now I think you were saying that sound must accelerate the medium, such as the medium will reach the speed of sound. I agree with that completely. Alright, let me think what he's saying here. Now I think you're saying that the thing making the sound must accelerate a medium such that the medium will reach the speed of sound. No. The thing reaches the speed of sound has no choice. The speed of sound is the speed of sound. It's the speed at which waves are propagated through the medium. What I'm arguing is the thing making the sound must move faster than sound to initiate that propagation through the medium. Anyway, the loudspeaker accelerates the air. However, when the air leaves the speaker cone, it isn't necessarily going the speed of sound. It isn't necessarily, well, it has to be going the speed of sound as soon as it's in the medium, so I don't see how that's possible. There's no transition. You know, there's not like some barrier of 5 inches or something where it's not going the speed of sound and it decides to start going the speed of sound. So the wave, once it's in the medium, must go the speed of sound, and so that's a given. The point is that the wave itself, in its form, was created by a function going faster than the speed of sound, because obviously the function had to create this extra distance. Just think of this wave as extra distance. Think of this instead of a straight line, and think of this as being like in a period of time. If this was a straight line, the thing would be twice as far away, and so half of its speed, half of its distance is caught up in this, and so this is an acceleration in speed. For those two things to have been the same thing, this acceleration in speed is necessary. You have to go faster to go more distance in the same amount of time, and that's essentially what's taking place. Alright, sorry, I agree. The loudspeaker accelerates the air. However, when the air leaves the speaker cone, it isn't necessarily going the speed of sound, but the air continues accelerating until a sound is produced. Will you say the air continues accelerating? I don't think that. I see. Where do you get that from? So you're almost implying that there is acceleration after it leaves the speaker. That somehow when it leaves the speaker, it's going this fast. It's going this fast after it leaves the speaker, and it somehow starts going faster as it gets further away from the speaker. It starts going faster. That doesn't happen. Continues accelerating until a sound is producing. Yeah, no. It would be like when air reaches well, it says thermal velocity. I guess that's terminal. Yeah, I know, but it can't do that without extra acceleration. So I just think it doesn't make any sense to say. So you're almost bending the principle here. Okay, peak acceleration is at initiation. You're almost arguing that peak acceleration is happening somewhere in here, and that's where there's peak deceleration. That's where there's no acceleration. So yeah, I just don't buy the argument. No, this isn't the right way to say it. All right. Continuous acceleration. It would be like when the air reaches terminal velocity, the speed of sound, a sound is produced, but this is not a sonic boom. A sonic boom happens when something traveling through the air reaches the speed of sound. Now it's when it exceeds the speed of sound. But regardless, the point is that accessing of the speed of sound is still my argument. I don't think you demonstrated how I'm wrong, and I don't think you've explained. If you can show me where your formula will tell you what the acceleration of the wave is at time 0, at time 1, 2, 3, 4, say peak at 10, let's call this 10, at time 10, you can tell me the velocity at time 10 and at time 0 and at time 2.5 or something, and you might be making an argument. But until you can show me how you're accounting for this initiation velocity, which is this, where I'm claiming the speed of sound is broken. Sorry for the long comment. Are we on the same page now? No, we're not. So anyway, so the Roberto guy did make a comment saying this formula was right, even though he doesn't show the formula in this comment. And the other guy did, the Roboto guy. But anyway, the function of time in his formula is not a function of the period within the wave. The function of time is based on distance traveled completely. So time is this big thing, not this little subdivision of inside the frequency. So unless your time scale is inside the frequency, you know, many times inside the frequency, 100 times, 1,000 times smaller units of time, you're not going to be able to use your formula to tell me how fast, what the initial velocity was. So I want to know initial velocity, this velocity versus this velocity. And you're not giving me those numbers. So I don't see this as a challenge to what I have stated. And I will continue to assert my hypothesis until you make a counter argument. Like I said, just produce a velocity at these different periods of time within the creation of the wave function. Show me that the hand doesn't move faster than the speed of sound, theoretically, if I were to be capable of creating a 10,000 hertz wave in a rope. Demonstrate to me that my hand wouldn't have to move faster than the speed of sound to initiate that wave. So anyway, I think I've gotten it. I believe I have. Okay, anyway. So, till next time. And such. I don't think I have anything terribly interesting to add. I mean, look, all this isn't that important. I just think I think it's really important in the sense that it's just important that if this is correct, that people understand what's really happening when sound moves through the atmosphere, that it is this little sonic boom thing. I think that's very interesting. But besides just the academic interest of it, it's also, I think, important to understand that there are different mechanical, electromechanical, there are different forces tying things together. I don't even like calling them forces anymore because I think they are physical structures. But regardless, there's structure holding atoms together. And you can affect different levels, different depths of that structure. You can touch me in the skin and put pressure on my skin, or you can hit me at the bone and push the bone. And those two things are different, and molecules have the same kind of different structure and different depth to their structure. And you can transmit energy through different levels of an atom structure. Yeah, that's a good way to say it. And I think that's really important stuff. It all has to do with this stuff always vibrating. You know, the fact that matter is always active, even when it looks inactive. And that explains a lot of this quantum stuff in the end, I believe. But anyway, we'll get there eventually. So till next time.